Well, hello guys and welcome back to Mr. G Physics. This is Mr. G and today we're going to be solving a question for the grade 10 related to electric circuit. This was question 7 done in June 2023 in the Northern Cape province. This question says consider the circuit given in the diagram below, and then you have a circuit here which you have 3 resistors and you have some ammeters, some voltmeters to measure potential difference and current on some parts of the circuit. The question 7.1 say define potential difference, and then we can say that work per unit charge. So potential difference is work per unit charge. Note that that is the formula. Potential difference, if you write it in symbol, is equal to W divided by charge. This is potential difference, right? Now what you need to know here, the W stands for work. W stands for work or also energy. Either work or energy, in which the unit is joules. Alright, and now Q is for charge. You already know that one, so I'm not going to speak about that one. This one is for potential difference. If you state that definition, you'll get 2 marks, guys. You make sure you get that definition. So calculate the total potential, the total resistance of the circuit. Now, for this part, we need to come back to the circuit and identify in what way are the resistors connected. We have to remember that the total resistance of the circuit is going to be the resistance in series plus the resistance in parallel. That is the first important thing we have to know. So now, if we follow here the current, we have a part of the circuit where the current split. So as you see here, the current comes all this way, but when reach this point, split in 2 parts. Alright, so this part of the circuit is in parallel. But here, the current comes again together and join in 1 point. So the 3 ohm is in series, but the 6 and the 12 are in parallel, and then they are in series with the 3. So the first thing we're going to do is to calculate the resistance in parallel here, which we are going to do on this side here. Remember, 1, let me just change that color. 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. Alright, and then we substitute. We have 1 divided by 6 plus 1 divided by 12. Alright, and we get that this one is equal to 1/4. So 1 divided by Rp is equal to 1 over 4. But note, we're looking for Rp, which is the denominator. So we come back here and we say Rp is equal to 1/4 to the negative 1. In other words, Rp is equal to 4 ohm. So this is important. Now we come all the way here to substitute in Rt. Alright, we have, which is 3 plus 4, which was the resistance in parallel, and we have that the total resistance is equal to 7 ohm. That is how to calculate the total resistance. Now, because you have only 2 resistors, there is another way of calculating the resistors in parallel. So we can say that R in parallel is equal to R1 multiplied by R2 divided by R1 plus R2. This one can also be applied if you have 2 resistors, like in this case. So Rp is equal to 6 times 12 divided by 6 plus 12, and will give you 4 ohm. So this one is a other option to calculate the resistors in parallel. You can use either one, but this one is only if you have 2 resistors. Guys, this is question 7.2. Alright, 7.2. And then you will get 1 mark for the formula of the resistors in parallel, either one of the 2 resistors, the one for the substitution, one for the addition of 3 plus 4, and one for the final answer. They'll give you 4 marks. Now, if we go to question 7.3, they say the potential difference across the 3 ohm resistor is 9. Calculate the reading of the voltmeter. Alright, so now, in this question, they say that the potential difference here in the 3 ohm resistor is 9 volts. Alright, so this one is the potential difference. They calculate the reading of the voltmeter V, and now voltmeter V is reading only for 12. So this question is not that bad, but it's a little bit tricky here. So this is question 7.3. Alright, now what we need to know, remember this circuit is a combination of series and parallel. We already spoke about that one. So in this circuit, the total potential difference will be equal to the addition of potential difference in series plus the potential difference in parallel. Alright, but in a parallel part of the circuit, in other words, in this parallel part, the potential difference in parallel will be the same everywhere because they are in parallel. Remember, potential difference in parallel is the same, which in this case is equal to V because that is in the parallel part. Alright, so if we come in back here, we have that the total potential difference is 21. You can see it here. Alright, that is potential difference of battery. So this one is 21. The potential difference in circuit is given to us and it's 9, and the potential difference in parallel is V, which is what we are looking for. So the potential difference through the 12 ohm resistor is equal to 21 minus 9, which is going to be equal to 12 volt. So the potential difference through the 12 ohm resistor is 12 volts. And there is 3 marks for that one for this formula, 1 for the substitution, and 1 for the final answer. It's quite simple. You just have to remember and notice what happened to the potential difference in a circuit. Determine the reading of the ammeter A2. Now, for that ammeter A2, guys, we're going to use the simple formula of current equal to potential difference divided by resistance, and this one is 7.4. This one is Ohm's law, and we can apply it because it's entirely easy. It's very, very easy. So we're looking for the current in this case here. So we need the resistance that is going to be there, and we need the potential difference which we just calculate. So guys, this is really, really easy. The potential difference was calculated, that is equal to 12. The resistance is 12 as well, and then the current is equal to 1 ampere. So the current that flows through the 12 ohm resistor is 1 ampere. And guys, we get 3 marks, 1 for the formula, 1 for the substitution, 1 for the final answer. And question 7.1, calculate the amount of charge that passed through the 12 ohm resistor in 2 minutes. And for this question, we need the definition of current. Now remember, current is the rate at which charge flow. So current is equal to charge divided by time. This is what we know. This one is the definition of current, and we can use it here. So if we rearrange for charge, which is what we are actually looking for, we have that charge is equal to current multiplied by time. And then when you substitute here, the current is 1 and the time is 2 minutes, but we cannot work in minutes, so it will be 2 times 60. We converted 2 seconds. In other words, we have that this one is 120 coulombs. Guys, 3 marks for this one. There is 1, 2, and 3. Quite simple. That is the answer for this specific question, and I hope you understand. This is all. This is a question on electric circuit for the grade 10. Is applicable to grade 11 as well. But thank you for watching. I hope it helped. Subscribe for the channel, thumb up, write messages. I see you next time. Mr. G here.